video, we want to look at angles in standard position. And before we do that, we have a lot of definitions that we need to look at. The first is that of a ray. A ray consists of a single point, which I've labeled here as E, and all of the points on a line extending in one direction of that point. Like this. That first point that we started with is called the endpoint. When we refer to a ray, we do it by stating its endpoint and any other point along that ray. So if I label another point along this ray F, we would write this as EF with this arrow over it. The endpoint is always listed first, and then any other point can be listed second. Next, we want to define an angle. An angle is the union of two rays that have a common endpoint, and this common endpoint is known as the vertex. Like this here. In this case, the common endpoint, or the vertex, would be E. When we write this, we write one point along one of the rays, then the vertex, then a point along the other ray. So this angle could be called angle DEF or angle FED. As long as the E is in the middle, which one comes first and which one comes third doesn't matter. And if it's not ambiguous, we often will call this just angle E. Angles are often referred to using Greek letters, so let's look at some of the Greek letters that are commonly used. The first is theta. The next is phi, which may be written in two different ways that you can see here. Typically, this first one is how we write it when we're handwriting, and the second one is how it's typed, but we could see it in either variation. We have alpha with this symbol here, beta, this symbol here, and gamma, this symbol here. Theta and phi are used most often, but occasionally we do use alpha, beta, and gamma for looking at angles as well. When we create an angle, we often start with two rays that actually lie on top of each other. We leave one fixed and we rotate the other. So we often draw these little arrows inside of an angle to indicate which direction they were rotated. The fixed ray, where it starts, is known as the initial side. And the rotated ray, where it ends, is known as the terminal side. And then once again, that shared endpoint is known as the vertex. So here I have an angle fully labeled. When talking about an angle, one thing that's important is the measure of an angle. The measure of an angle is the amount of rotation from the initial side to the terminal side. One of the common ways to do this is a degree. 1 degree is 1 out of 360 of a rotation. This means a full circular rotation contains 360 degrees. Let's suppose I want to draw an angle that measures 90 degrees. We know 1 degree is 1 over 360 of a rotation, so let's multiply 90 times 1 over 360. When we do that, we get 1/4. This means that a 90-degree angle will be 1/4 of a rotation about a circle. So we can see that here. We tend to draw little boxes on 90 degrees rather than arrows, but we can see our 90-degree angle here. Now that we've looked at some of the basics of angles, let's actually look at what it means for an angle to be in standard position. First, we need the vertex to be at the origin, and we need the initial side to be along the positive x-axis. Here, I can see two examples of angles in standard position. Both of them have their vertex at the origin and their initial side is along that positive x-axis. Angles can be both positive and negative. A positive angle moves in the counterclockwise direction from the initial side to the terminal side. Here's an example of a positive angle in standard position. That rotation, that center rotation, is moving counterclockwise. A negative angle, on the other hand, moves in the clockwise direction. Here, I can see an example of a negative angle because it is that rotation is moving in the clockwise direction. There are special angles known as quadrantal angles. A quadrantal angle is one whose terminal side lies along an axis, and there are 4 big quadrantal angles. The first is 0 degrees, where the initial and terminal side are the same along that positive x-axis. The next is a 90-degree angle. This time the terminal side lies along the positive y-axis. Next, we have 180 degrees. This time the terminal side lies along the negative x-axis. And finally, we have 270 degrees. This time the terminal side lying along the negative y-axis. Let's suppose we want to draw an angle of 30 degrees in standard position. Our first step, since we know a full circle is 360, is to divide by 360. 30 over 360 is 1/12. So now, I want to use that 12 in the denominator to break my plane up into 12 equal pieces. We can see that done here. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, 11, and 12 pieces. We always do our initial side along the positive x-axis, and the 1 in the numerator tells me I want one of these sections. So here is my angle that is approximately 30 degrees. Next, let's look at drawing an angle of negative 135 degrees in standard position. Once again, we start by dividing by 360. When we do that, we get negative 3/8. That 8 in the denominator tells me that I need to break my plane into 8 equal pieces. I've done that here. We have 1, 2, 3, 4, 5, 6, 7, and 8. Our initial side always goes along the positive x-axis. The 3 in the numerator tells me I want 3 of these 8 pieces, and the negative tells me I need to move clockwise. So that puts me here. That gives me 1, 2, 3 of my 8 pieces.